Hey, it's Roger, creator of the Azure Sandbox. I'm back, and we're picking up where we left off in our previous video where we had done smoke testing against the VNet app configuration. And we're going to do a code walkthrough based upon, some of the stuff that I included in the documentation. So the first thing that we want to look at is the bootstrap for VNet app. And each configuration has its own bootstrap, which has to be run in advance prior to provisioning the configuration. So we'll launch VS Code and pick up where we left off. All right, so we're in VNet app and we want to check out bootstrap. So it's a bash script. First thing we do here, starting in line 11, is initialize a bunch of constants. And then, this is kind of interesting, on line 29, we reference the state file from the VNet shared configuration. So we're actually going to go pull some of the output variables out of there and use those to drive the automation in this configuration. So I'm just initializing an environment variable to point to that state file. And as you can see, if we go look at VNet shared, here's the state file right here. Okay, that's referenced by that environment variable. Right, so do some error checking and make sure the state file exists. And then we can run these Terraform output commands to pull output variables out of them. And we can actually name the specific output variable that we want to output. So if we go, let's see, try this command. We'll go down into VNet app, and we'll do a Terraform output dash state equals, and then the state file is going to be at // Terraform. Here, let me just grab it from here. Be easier than typing it. Put it in quotes so nothing gets messed up. And then the variable that we want is, say, AAD tenant ID. Boom. So it returns it in quotes, so that's a little bit annoying. I wind up having to strip those quotes off later, and I'll show you how I do that. But here is where we go and grab and populate environment variables from that previous VNet shared configuration. So this is an example of one, the state information associated with one configuration driving the automation for a second configuration. Right, here's all of our user input statements for the various variables that we may want to change. And we basically went with all the default settings, but those can be changed. And here's where we just check to see if a blank value was provided, and if it was, we just reinitialize it to the default. Do a little bit of validation. We make sure that you set up your environment variable for your service principal secret. And here's where we check the input to make sure you just said yes or no if you wanted to skip the generation of the SSH keys for Jump Linux 1. And then here's the commands for actually generating the SSH keys. So we use SSH keygen, and you can see that we are, referencing the admin username and the admin password as we generate those key files. So we're going to have the same, Bootstrap admin default admin username and the same strong password that we're using to authenticate everywhere else. We're going to use that to secure these SSH keys. So there's two files that come out of that, a public key, which I named .pub, and then a private key, which has no file extension. And then what we do is we read those files into environment variables. And then once we do that, we can, this is where, the admin username secret, we pulled that from an output variable. Remember, it had quotes around it. So here you can see how I'm stripping those quotes off with this syntax. So this takes off the first and the last character, which are both quotes. And we go and get a secret from the key vault. And then we go set some secrets based upon the SSH keys that we just generated. So the public key, we create a secret for the public key for the SSH key. Those are these lines of code, right? And we create a secret for the private key as well, for the SSH key for Jump Linux 1. Now, in this section, we're going to finally use that container that we created in VNet Shared to upload some scripts which get run on our VMs after they get deployed. There's two variables for each script. There's the script URI, there's actually two scripts here, and I need to provide a URI for both of them. So that when I can reference that URI from my VM extension, my custom script extension. We grab the key. That's how we, that's how we secure the scripts, is using the storage account key. And then what we do is we upload all of the PS1 scripts in the current directory into that Azure Blob storage container that we created in VNet Shared. And let's see, there's a couple of those scripts in this directory. Like there's this AADSC register nodes, there's this configure automation, configure PowerShell, configure storage Kerberos script, configure jumpbox win, and this jumpbox config.ps1. So I don't actually need to upload all these scripts, so I was a bit lazy. I just said take all of them and put them in the container. Only a couple of those scripts actually get referenced by custom script extensions. Right, so next we have to fix up our automation account. So our automation account was previously used to configure our Active Directory Domain Services Domain Controller, VM, in VNet Shared, which is called ADDS1. We're going to use it in this configuration to configure the Windows Jumpbox VM, JumpWin1. And so we need to prepare the automation account to do that configuration. And so to do that, we're actually going to run a PowerShell script, which is called configureautomation.ps1. So let me open that up so we can have a look at it. We'll just take a look at the main routine instead of going through all the subroutines. So Um, what we do first is we connect up to Azure and we set the default subscription and we initialize a variable to point to our automation account. And here's where the real work begins. So first thing we're going to do is import the Chocolatey Azure Automation Desired State Configuration module. So Chocolatey is a package manager for Windows, and using Chocolatey, you can install a bunch of other software on a VM, a Windows VM. Here, that's the only module that we had to add. Here we're going to import a DSC configuration for Windows Jumpbox, and that's called jumpboxconfig.ps1. We'll take a look at that next. And then we're going to compile that configuration, jumpbox config, which creates that MOF file that has all the binaries in it, which then Azure Automation DSC will push down onto our Windows Jumpbox VM. Okay, so I'm running. That's all the pre-configuration work that Bootstrap does against our automation account using this PowerShell script. And if you look at the configuration of Jumpbox config, so this is the desired state configuration for our Jumpbox VM. So we just pass in the computer name, and then we reference 4 modules, including a module to domain join it, to do some Active Directory operations, and also to install some software using Chocolatey. Pull a couple variables from Azure Automation, the name of our domain, and also the credentials for our domain administrator. And then here's the actual configuration itself. So here on lines 16 through 19, we domain join the VM. And then here we add a bunch of remote server administration tools to our VM. And there's really like 4 of them, I think. We add the remote server administration tools for administering Active Directory with PowerShell. We add the Active Directory domain services administration tools. We add some DNS administration tools. We add some clustering administration tools. That's useful if you're going to be testing things like SQL Server Always On. In the sandbox, you might need to create and administer some Windows Server failover clusters. Yeah, so we install both the tools and the PowerShell modules associated with Windows Server failover clusters on our Jumpbox. So again, super useful if you're going to be, creating Windows Server failover clusters up in Azure. Those are all administrative tools you'll need, and they're all pre-installed on your Jumpbox. Here, I am creating an Active Directory security group called Jumpboxes, and I'm automatically including this computer in that security group. And that's useful if you're going to be doing things like, setting up permissions or group policy, and you want a security group to reference all your jump boxes. So if the group doesn't exist, it'll get created. If it does exist, it'll just leave that existing group in place, and in either case, it will add the current computer to that group. And here's where we install Chocolatey. And once Chocolatey is installed, notice we've got dependencies in all these. These all say, hey, I need Chocolatey installed in order to do this. We install Edge. We install PowerShell. We install VS Code. We install SQL Server Management Studio, Azure Storage Explorer, AZ copy, Azure Data Studio, and MySQL Workbench. And these are all open source chocolatey packages that, with just a few lines of configuration here, I'm pushing all of this very useful software onto our Jumpbox VM. Okay, so I believe we left off on Bootstrap. Our automation account's now configured, everything's compiled, we're ready to go. Here's where I write out my terraform.tfrs file, again with a bunch of printf statements, right? And then I cat it out, and we're done with Bootstrap. So that's a quick code walkthrough of Bootstrap. Let's see if I missed anything. This configuration uses Bootstrap to create Terraform TFRs. For simplified deployment, several runtime defaults are initialized using output variables stored in the VNet shared configuration. So here I've documented all of those dependencies on that other configuration. We upload a couple of scripts to storage account, these two, so that we can push them onto the VM using a custom script extension. And then we configure Azure Automation desired state configuration. We did a code walkthrough of this configure automation.ps1 script. We talked about the things that script does, how it adds the chocolatey module, and how it imports the jumpbox config.ps1 DSC configuration and compiles it.